Hello everyone, welcome back to this channel. Today we are going to talk about the chain rule. So by the end of this video we should be able to identify composite functions, apply the chain rule step by step, solve both simple and advanced problems confidently. So before we dive into it or touch any formula, let's build some intuition right here. Now differentiation tells us how fast a function is changing. That is the rate of change. But what happens when one function is wrapped inside another? That is what we call the composite function. So let's say we have the function y is equal to sine of 3x. So here the sine of x is the outer function. And the 3x is the inner function. When you differentiate this, you can't just treat it as a single piece because both the sine and the 3x affect how the function changes. So the chain rule helps us chain these rates of change together. So it's like saying if y changes when u changes and u changes when x changes, then y must also change when x changes. It's a little bit complicated. Let me go over again. What I'm saying is that it's like saying if y changes when u changes and u changes when x changes, then y must also change when x changes. So let's put all these statements in mathematical form. So mathematically, what I mean is that if you have dy over dx should be equal to dy over du times du over dx. That is the whole entire idea behind the chain rule. So if y is equal to f of g of x, then the chain rule says that dy dx should be equal to f prime of g of x times g prime of x. So in words, what we are trying to say is that differentiate the outer function while keeping the inside the same. Then you multiply the derivative of the inside. That's what we are trying to say here. Now let's start with this simple example right here. So let's say we have y is equal to 3x plus, let's make it 2 exponent 5. So the first step is that we need to identify the outer and the inner function. So what will be our outer function? So for me, my outer function will be equal to, or will be u exponent 5, and my inner function will be 3x plus 2. Right? So the next thing that we need to do here is to differentiate the outer function. So if we are to differentiate the outer function, this is what we are supposed to get. So we know that our outer function is u exponent 5. So when we differentiate, we should get 5u exponent 4. Right? Now, the next thing that we need to do is to multiply by the derivative of the inner. What is the derivative of the inner? It's 3, right? So my derivative of the inner is 3. So with this, we can see that the dy dx will be equal to 5 multiplying 3x plus 2 exponent 4 times 3. If you get it clear, so when you multiply that, we should get 15 multiplying 3x plus 2 exponent 4. And this will be our final answer for this question. Very simple. Now let's try another example right here for us to get the understanding very clear. So with this example, we have y is equal to sine of 5x squared. So with this, what will be our outer function? So our outer function will be equal to sine and its derivative. Okay, so let's write the its derivative. So its derivative will be cosine. If you understand it very clear here. Now step 2 is to find the inner function. What will be our inner function? So inner function will be the 5x squared, and the derivative will be 10x will be 10x. Now when we are done with this, we can just come back and write that then dy dx will be equal to the cos of 5x squared multiplied by 10x, right? And our answer will be 10x cos of 5x squared. So you can see what we are talking about here with this kind of example that we provided right now. Okay. Now one thing that we need to know is that the 10x comes from the inner function, which is the 5x. So without it, you will underestimate how fast the entire curve changes, right? So the 10x comes from the inner function, which is the 5x squared. So just remember that. Now let's look at this example as well. So in this example, we have y is equal to e exponent 4x exponent 3 plus 2x, right? So this one we have this. So first thing that we need to do is to locate the outer function, right? So with this, our outer function will be the e exponent u. And what will be our derivative of this? So our derivative of this will be eu. So the same thing, right? Now what will be our inner function? So our inner function will be 4x exponent 3 plus 2x, and its derivative form will be 12x squared plus 2, right? So now we can use this to solve use the chain rule to solve this. So with this, we will have dy dx will be equal to e exponent 4x exponent 3 plus 2x multiplying 12x squared plus 2, right? So with this one, our final answer will be 12x squared plus 2 multiplying e exponent into bracket 4x exponent 3 plus 2x. Right, then we have our final answer. So this is a little bit advanced, and I hope you understand. So what we are trying to do right now is to use the chain rule to solve this type of questions. So you can also go through as well and see how it goes. Now let's look at another example right here. Now this example is logarithmic function, right? So with this logarithmic function example, we have y is equal to the natural log of 3x squared plus 4x plus 1. Right, now you can pause the video and try to find the inner and the outer function. Then we'll continue from there. And I hope you did and found your inner and outer function. So let's identify our inner and outer function. So with this, our outer will be the natural log of u. And what is its derivative? You can pause the video, also try to find that. The derivative of the natural log of u is 1 on u. Now, what is our inner function? So with this, our inner will be equal to 3x squared plus 4x plus 1. And what will be our derivative of this? So that one will be 6x plus 4. Very simple, right? Now, when we are done with this, we can use the chain rule to do that. Now, our chain rule, we have dy dx should be equal to 1 on 3x squared plus 4x plus 1 multiplying 6x plus 4. Now, when we multiply this, we should get 6x plus 4 divided by 3x squared plus 4x plus 1. Now, let me give you one tip here for this type of question. Now, for any natural of f of x, okay, so any natural log of f of x, you just have to use the formula dy dx should be equal to the f prime of x divided by the function, which is f of x. Very simple. You can use that and use to do it, you get the same answer. That's just a tip. Okay, now let's go to another example right here. Now with this example, we have multiple layers, so we are going to use this is an example with multiple layers. So let's see the example. So with this example, we have y is equal to cos squared multiplying 2x cubed plus x, right? So we are going to find the derivative of this. Now, this question have 3 layers. We have the first one, we have the squared term. And the second one, we have the cosine. And the third one, we have the polynomial inside, right? You can see it from there. So let's handle them by one by one and see how it goes. So for this, we have, let's rewrite our question here. So we have y should be equal to, into bracket, cos of 2x cubed plus x all squared. So when we do it again, this is how we are going to get it, right? Perfect. Now, let's find the derivative of the outer layer, okay? Derivative of the cosine, derivative of the inside. So we are going to have 3 things right here. So the first one is the derivative of the outer layer. which is u squared, and its derivative will be 2u, right? That's the first thing. Now the second thing here is the derivative of the cosine. So what is the derivative of the cosine? You can pause the video and try to figure that one out, of cosine. And that one will be negative sine of 2x cubed plus x, right? Now the third and the last one is the derivative of the inside one, and that one will be 6x squared plus 1. Okay, now the chain, we have to chain all of them together using the chain rule. Okay, so with this we will have dy dx will be equal to 2 multiplying cos of 2x cubed plus x. Then you close the bracket, then you bring the big bracket right here. Then we multiply by negative sine of 2x cubed plus x. You close it, then you multiply by the last one, which is 6x squared plus 1. Then we simplify it. I hope you can simplify this. You can pause the video and try to simplify this. So if you are done with this, let's look at the simplification of this. So with this one, we have dy dx will be equal to negative 2 multiplying 6x squared plus 1. Then we have sine of 2x cubed plus x. Then we have cos of 2x cubed plus x. Very simple. So in all, this will be our final answer. That's how the simplification will be. I hope you got the same answer as mine. Now let's look at this question right here. So in this question is kind of a fractional power function. Okay, so with this one we are going to find y should be equal to square root of 4x squared plus 1. Now with this, let's rewrite it as y is equal to 4x squared plus 1, then exponent half, the same as the square root, right? Now when we are done with this, we can find the outer and the inner function. So with the outer function, we have u exponent half, and its derivative will be half multiplying u exponent negative 1, 2. Then the inner function will be 4x squared plus 1, and its derivative will be 8x. So with this, we can simplify it as dy dx should be equal to half multiplying 4x squared plus 1 exponent negative half times 8x. Then with this, lastly, we will have dy dx as 4x exponent. We can bring this one down, then we will have the root of 4x squared plus 1. So with this one is the square root, and because it's negative, we bring it down as an inverse, right? Then we get the answer right here. So this is our final answer for this type of question. Look at this final question and we'll end this video right here. So with this question, we have y is equal to x squared multiplying e exponent x cubed. All right, so here we are going to use both product rule and the chain rule together. So with the product rule, so let's use the product rule first. So with this, we have dy dx equal to the u prime v plus u v prime, right? So now let the u be equal to x squared and the v be equal to the e exponent x cubed. So the u prime will be 2x and the v prime u, we have the 2x, and for the v prime we are going to use the chain rule to do that, okay? So the chain rule to solve that. Now the outer derivative of, so the outer derivative, which is the e exponent u, will be equal to e exponent x cubed, and the inner derivative (3x squared). So for v prime will be 3x squared e x cubed, right? So now that we have figured all these things out, we can just go ahead and use dy dx will be equal to 2x multiplying e exponent x exponent 3 plus x squared multiplying 3x squared, then e exponent x exponent 3. So then when we are done with this, we have to simplify it to get the lowest answer. So the simplification of this will be dy dx will be equal to e exponent x exponent 3 multiplying 2x plus 3x exponent 4. So this is our final answer for this. Okay, this is our final answer, and this is the end of this video. I hope you found this video helpful, and thank you for watching. Don't forget to subscribe to this YouTube channel, and I'll see you in my next video.